Today we're going to finish our lesson 8.5. In the first half of this lesson, we looked at graphing inequalities. Today we are shifting to graphing systems of inequalities. And it says here the solution points are the regions that the inequalities have in common. In other words, it's where their graphs overlap. So what we're going to have here is we're going to have two different lines. We'll be shading for each of those linear inequalities, and then we are going to look for where those shading areas overlap. You should get in the habit of trying to make precise graphs, finding those exact points for your x and y intercepts, because as we move into our next section, we are going to have to find those vertices of where the intersection of those shaded areas will be. So we do want to be precise. So our first one, we have two equations, our two inequalities. X minus y is greater than or equal to 4, and x plus y is less than or equal to 6. I have color-coded them so that we can tell as we graph which equation or inequality we're looking at. So for the first one, x minus y is greater than or equal to 4. We want to find our x and y intercepts. So if we put a 0 in for x, we have negative y has to be equal to 4. Dividing out the negative, we would have y being negative 4. So my y-intercept is going to be at negative 4. If I put a 0 in for y instead, now I have that x has to be a 4. So my x-intercept is going to be a positive 4. All right, and then we want to connect those points with a line. Again, you want to try to be as precise as possible. And then we have to determine if we are going to shade above or below that line. So we test a point. So pretend we put the origin in. Is 0 greater than 4? Since it's not, we don't want to shade the origin. We would be shading underneath. So on your paper, I'd like you to lightly shade the area underneath that red line. I'm going to just put an arrow there since on the smartboard here I can't shade it in lightly. All right, shifting to our second inequality. We have x plus y has to be less than or equal to 6. Again, when we find our intercepts, we're just pretending there's an equal sign there instead. So x plus y equals 6. If we put a 0 in for x, we have y being 6. And if we put a 0 in for y instead, we have x being 6. So we have x and y intercepts of positive 6. Again, we're going to connect those with a solid line since we don't have an since we have an equal sign. We want a solid line there. All right, and then testing that point, if we put 0, 0 in for x and y, is 0 less than 6? Since it is, we do want to shade the origin, so we're going to shade that direction. So we basically want everything underneath the blue line, and we want everything underneath this red line. So the place where they have an overlapping section would be this region down in here. All right. Looking at our second example, x plus y has to equal 4 to find our x and y intercepts. So again, putting 0 in one at a time, we have y being 4. Putting a 0 in for y, we have x being 4. And we'll go ahead and connect those. Once again, we have a solid line because there is an equal sign in that inequality. And then testing a point again, if we check the origin, if we put zeros in for both x and y, do we get a true statement? We have 0 is less than 4, that is true, so we are shading everything below that line. For our second inequality, it is already in slope-intercept form, so we technically wouldn't have to put in our x and y intercepts. We could just graph it using our y-intercept and our slope. So here's our y-intercept of negative 4. And our slope is 2 over 1. So we're going to rise 2 and run 1. All right, and then we're going to draw a line through those points. All right, and again, testing the origin, if we put 0 in for x and for y, we have 0 has to be greater than or equal to -4. Since 0 is greater than -4, we would shade the origin, which would be this direction. So again, looking for the place where those overlap, we would have this region here. All right, our third example. Notice on these, we do not have equal signs, so we are going to have dotted lines instead. Our first one, finding our x and y intercepts. If we put a 0 in for x, y has to be 3. And if we put a 0 in for y, then x would have to be 3. All right, so once again, we're going to connect those with a line. And then we're going to test the origin again. If we put zeros in for both x and y at the same time, we have 0 being greater than 3, which is not true. So we do not want to shade the origin. We're going to be shading away from that origin. For our next one, putting a 0 in for x, y has to be -2. We'll plot that point. Putting a 0 in for y, we would have x being -2. Connecting those with our line. And again, we have to test the origin. So if we put in 0 and 0 at the same time for x and y, we have 0 is less than -2. Since 0 is not smaller than -2, we don't want the origin shaded, so we are going to be moving that direction. So in this case, we do have parallel lines, and they would never intersect, so we are going to put down no solution for this. All right, our fourth example here is a little different. We do have two inequalities, but they're combined into one compound inequality. So I want you to think of breaking this into two parts. If we look at the left side, we're saying -2 has to be less than y. That would be the same as saying y has to be greater than -2. So if we think about that in terms of horizontal and vertical lines, y being greater than -2, we have a horizontal line at -2. It would be dotted. And we want y to be greater than that, so we would be moving upward. If we look at the second half of it, we're saying y has to be less than or equal to 5. So that would be a solid line up at 5, and we want y to be smaller than that, so we would be moving downward. So the effect of that is that our overlapping region would be all the space in between those two. All right, our last two examples have a few more inequalities in them. I do want you to look at the first one here and think about what would happen if we were to graph both of those and look for where they overlap. So we want x's to be greater than or equal to 0, which would mean all of this. And then we want y to be greater than or equal to 0, which would be along the x-axis and everything above. So the net result is that we are in quadrant 1. All right. Now this can get pretty messy when we have a whole bunch of inequalities to graph. So I'm fine with you analyzing those two inequalities and basically just writing down that this means we are in quadrant 1. Okay. So we're locked into quadrant 1, and now let's go ahead and graph the second two inequalities. The first one has a less than symbol in it, so it would be a dotted line. Putting 0 in for x, we have 0 plus y has to be equal to 4, so my y-intercept would be a 4. Putting a 0 in for y instead, we have 2 times x has to be equal 4. That means x would have to be a 2. All right, so we're going to go ahead and connect those with a line. It is going to be dotted. All right, looking at our blue one, putting a 0 in for x, we have -3y has to equal 3. So y would have to be -1. And then if we put a 0 in for for y, we have 2x equals 3. Dividing out the 2, we'd have x equals 3/2 or 1.5. So our y-intercept is at 1.5. All right, connecting those two with a line. And then we need to look at our shading. For the red one, top inequality here, if we put zeros in for both x and y, we have 0 is less than 4. That is true, so we are shading this direction. For the blue one, if we put zeros in for both x and y, we have 0 is less than or equal to 3. Again, that's true, so we want to shade towards the origin. So the effect, since we have to be in quadrant 1, we are locked into this region. And now we have to be above the blue and below the red. So we are looking at this little section right in here. Now, earlier in the notes, I said that we need to pay attention to the vertices of our shaded area. So we do have a vertex here at the origin. We would have one here at 0, 4. We have one here, and we have one here. Now, because of the dotted line, this point is actually not included, but it would be considered the vertex of that boundary. And we will talk more about that as we move into section 8.6. So our last inequality is a little different. If you think back to what we had in the first half of this section, we had an equation x minus h squared plus y minus k squared equals r squared. That was their equation for a circle. And we know that the center is at hk, and we know the radius is r. So for our first one, we have a circle. It has a radius of 4, and it has a center of -1, because we have to think of this as x minus -1. So we have a center at -1, +1. All right, so we're going to graph that point, and we want a radius of 4. So we're going to go 4 in each direction. There is no equal sign for that one, so we do want a circle that is dotted. And we want the radius to be less than, r squared has to be less than 16, which means r has to be less than 4. So we are shading inside that circle. For the second one, we have a center at -1 again, +1. So same center. This time we want the radius to be a 2. So using the same center, if I go out 2 spaces in each direction, this time my circle is going to be solid since there is an equal sign on that. And since I want r squared to be 4 and I want my circle to be greater than that, I'm heading out from that center. So the effect of that would be this ring. That's where they would overlap. All right, so for homework today, you are going to be practicing setting up systems of inequalities like that. And then tomorrow we will look at how we can use those overlapping areas.